I want to make 2 points in this video. And the first one is to foreshadow or to give some kind of a preview of the subclass version of that question about executing constructors and destructors, the order in which constructors and destructors execute. I don't want to do that with the full example that I have planned, so I'm going to do that first. So here I've got my fruit class again, and in this case, the default constructor for the fruit class prints out what it is, and there's the destructor, and there's the destructor is virtual. So I mentioned this at the end of the last video. For now, we're just going to make our destructors virtual. We'll come back to this next week. It's hard to contextualize what's going on until we have one more feature of the language. And there's getName and there's isDelicious. I'm going to come back to what's commented out there in a few minutes, and then I've got my Raspberry class. It's got getName, it's got isDelicious, it's got a constructor and a destructor, and they print out what they do. So what I want to talk about first is just to remind ourselves that a raspberry is a fruit. And remember that the raspberry class, by saying that it is a fruit, inherits all of the members of fruit. It is a fruit plus more. It's a fruit with some extra stuff that it adds itself, like this getNumSeeds function and some member data and whatever. And so I guess there's a question then, which is when I go to construct a raspberry, who is responsible for what? I guess I assume the raspberry class is responsible for constructing the numSeeds variable, because that's in the raspberry class. But doesn't the raspberry class contain all of the stuff stored in the fruit class? Who constructs that? And the answer is, it turns out the fruit class does. When I construct a subclass, I first call the constructor for the base class to set up all of the data that's inherited, and then I execute the constructor for the derived class. I'm going to begin by running that. And so what I have in main is a very basic version of the code from before, which is I make a fruit, I make a raspberry, I then print out the fruit, then the raspberry, and then the program ends. And what I'll observe is, okay, so there I'm constructing the object f, all right? And then below, when I construct the object raspberry, strangely, the constructor for fruit shows up first. And at the end, I notice the fruit destructor gets called twice. And I can emphasize this further because I could, let's just try commenting out all of the uses of f. All I have in my program right now is my variable r. And yet when I run it, there's the fruit constructor, and there's the fruit destructor. And you'll notice that the law of socks and shoes still applies. So the fruit constructor comes first, and therefore the destructor comes last. What's really happening, and we'll come back to this in greater detail in a different video, what's really happening is when I construct a derived class, when I go to construct the raspberry class inherits a bunch of its contents from the fruit class. And so it makes sense. The fruit class is what defined those contents. It is the thing that should construct them. So when I call the constructor of a derived class, the first thing that happens is we call the constructor of its parent, of its base class. So we call the fruit constructor, it sets up the part of the raspberry object that's the fruit stuff, and then when that's over, we then get into the raspberry constructor and finish setting up the remaining data. We work our way down the family tree. And when we destruct the class, the opposite thing happens. So first, I destroy all of the stuff that's relevant to the raspberry, that's raspberry only, and then I call the destructor for the fruit class to destruct all of the stuff that's property of the fruit class. That's why we notice the fruit destructor happens after the raspberry destructor. And the logic is pretty simple, which is, I think, like the justification for why it happens in this order is pretty simple, which is inside the constructor for a raspberry, I could use the parts of the class that were inherited from fruit. Therefore, it's important that those have already been constructed before the raspberry constructor begins. And conversely, in the raspberry destructor, I could use those parts of the class that it inherited from fruit. So it makes sense. I can't go destroying that stuff until after the raspberry destructor has ended. Okay, that's just a preview of that. We're going to come back to that in a different video, but I wanted to just lodge that thought in your brain. So what I'm going to do now is uncomment the rest of the testing code in main. So I've got my fruit object f, I've got my raspberry object r, and now we're back to the rest of the family here. So we've got the pumpkin and the pineapple, and I want to print those out as well. What I want to talk about isn't so much how to print them out, because we sort of know already this idea of upcasting and downcasting. What I want to talk about is what we do if we notice that we've already defined this family of fruits. So fruit, the various specializations of fruit are pineapple, raspberry, and pumpkin. What if we discover that there's more nuance to the family tree than we expected? So one example would be, what if we realize that, hey, you know, a pumpkin actually has seeds as well? If you've dealt with a pumpkin recently, you sort of know that it does. What if a pumpkin has seeds as well? Okay, now a pumpkin has seeds and a raspberry has seeds, but a pineapple doesn't, I guess. So I guess it's not true that all fruit have seeds. So is it reasonable that maybe if I notice multiple fruits have seeds, I should go add stuff about seeds to the fruit class? Well, maybe not. Maybe there are things that are common to some members of the family that aren't common to the entire family. But I might still, when I print a fruit out, I might want a way to print out the number of seeds in the fruit, whether it's a raspberry or a pumpkin. So how do I do that? Well, I mean, one option would be to say, okay, first off, see if it's a raspberry. And then if it is, print it out. And otherwise, see if it's a pumpkin. Just try casting it to pumpkin. And then if it is, let's just try that. So in this case, I'll say, I'm going to still call the variable r because it's a quick example. In this case, the fruit is a pumpkin, and we'll print out the number of seeds. Great. Okay, so we'll try that. And hopefully we can see that's a bit clunky. But sure enough, when we go to print out we print out that the fruit, so here's where we print out raspberry. We print, yep, it's a raspberry. It's got 6 seeds. It's not a pumpkin, okay. We go down here, we print out, okay, it's a pumpkin. It's got 1 billion seeds. But maybe you can see this is clunky, and I don't want to have to add another set of try-catch for every single fruit that could have seeds. I want some way of absorbing that functionality into one place. So maybe what I want to do is to diversify the family tree a little bit. Maybe what I want is to say, actually, there's more than just fruit and then specific things like pumpkins and pineapples and raspberries. There are fruits, and then there are fruits that contain, I don't know, visible seeds. So we'll call that seed fruit. And so there's a subclass of fruit called seed fruit. And then examples of seed fruit include raspberry and pumpkin. I'm going to add another layer to my class hierarchy. And so I'm going to do that. I've already created a mock-up of the class that I want. A seed fruit is a fruit. It's just a fruit that has one extra thing, which is some function that tells you how many seeds it contains. It also contains this private member variable called num seeds. Now I think about this for a moment and I think, actually, if I make this private, who is going to set it? Like, how is anybody going to set it if the class doesn't set it itself? We're going to meditate on this a bit. For now, though, I'm going to say, let's make this a protected member. So any of the descendants of the seed fruit class are allowed to use num seeds, but the outside world isn't. Notice also that the get num seeds function is virtual. So an alternative would be that the descendants of the class can choose to override this function. Okay, so now, let's see. I've got my raspberry class. The raspberry is now a seed fruit, not just a fruit. And we can adjust it further. So I no longer need a member called num seeds because the raspberry class now inherits the member num seeds from its parent, which is seed fruit. It also has a grandparent class, which is the original fruit class. Similarly, I don't need a get num seeds function because the parent gives me one of those as well. I inherit get num seeds from the seed fruit class. So instead, when you define a raspberry and you construct it, you give me the number of seeds. I will just set that in the constructor, and that'll be it. The raspberry now has the get num seeds function. What about the pumpkin? Let's try something different with the pumpkin object. In the pumpkin object, I could observe, hey, the number of seeds is always the same. I guess I could just set the number of seeds. Maybe we'll start by doing that. I want to show off one alternative, though. So the pumpkin object is a seed fruit. So it inherits the num seeds member variable, and it inherits the get num seeds member function. And in the constructor, the default constructor, it just sets the number of seeds to be some value. All right, and then down here, when I print it out, I'm not going to ask if it's a raspberry. I'm going to ask, is this a seed fruit? We'll call it S. So I'm going to say now, F has seeds. And here I'll say F does not have seeds. Actually, I'm going to say F has, and I'll print out the number. S.getNumSeeds. Seeds. So here I ask, is this an instance of the seed fruit class? A class that exists pretty much just as an easy placeholder for the various types of fruit that have visible seeds. And then I print out the number of seeds that it contains. And so we'll see what happens if we do this. I don't think I've missed anything obvious there. All right, so let's take a look. I print out the raspberry. It's delicious. F has 6 seeds. That looks like the right number. I take a look at the pumpkin, which is not delicious. F does not have seeds. Oh, I made a mistake. So the mistake was when I did my dynamic cast, I actually cast the object to type raspberry, which in some cases works and in some cases doesn't. In the case where it worked, I then immediately upcast the raspberry back to seed fruit, which obviously is incorrect. What I wanted to do is do a dynamic cast to seed fruit. You give me a fruit, I try doing a downcast, only partially down, just to seed fruit, and then I cast it to that and then see if that works. That's why the pumpkin apparently had no seeds, because a pumpkin is not a raspberry. Okay, so now it works. In this case, it says the pumpkin is not delicious, but it has 1 billion seeds, whereas the raspberry has 6 seeds. So in both cases, it was able to absorb both of those situations into this try-catch block, where it asks, is it a seed fruit? If so, how many seeds does it have? And so what I've done is I've defined some middle layer of the hierarchy for the case where there is functionality common to some, but not all members of the family. So a few other notes to make here. One of them is this. There is another option I have with the pumpkin. So with the raspberry, it'll suffice for me to just set the number of seeds in the constructor. We saw that that worked in the pumpkin class as well. What if I try this instead? What if I override the getNumSeeds function? So I don't even use the member variable getNumSeeds. Instead, I just do this. I just return, I make my own version of the function that overrides the one in the seed fruit class that just returns a constant. It doesn't bother with the variable, it just returns something itself. In a very similar vein to what happens with getName, which just returns a constant string. And you can see it still works. When I call getNumSeeds, because it's virtual, I get the version that goes with the true type of my object. And in the case of the pumpkin, that's this function that returns some constant number. And so I strangely bypass this variable that I inherit from the seed fruit class, but I'm allowed to do that. I'm in control when I'm writing the pumpkin class. So there's that. There's one other note, one other thing I sort of want to lodge in there for later, which is there are a couple of other things we could do with the seed fruit class, but one thing that should alarm us a little bit about both seed fruit and the basic fruit class is they are clearly not intended to be fully fledged things. They're almost sort of catch-all, sort of easy ways of classifying stuff. Names we can use to generalize something specific, something that is real, like a pineapple or a raspberry. I don't know if I want anybody to actually create objects of type generic fruit or objects of type generic seed fruit. That doesn't seem correct. It seems inadequately specified. What could I do in a case like that? That is something we're going to come back to in a future video. And then there's one other note here that I wanted to make, which is suppose I want to investigate the various ways of protecting the variable numSeeds. I think, I don't know if I want even the subclasses, even raspberry and pumpkin, modifying this variable directly. What other options do I have? We know already that if I make numSeeds private in seed fruit, then I'm in some trouble. So if I try compiling that, it does not work. It says, sorry, if numSeeds is private inside the seed fruit class, let me see if I can jam this onto one screen. If numSeeds is private in the seed fruit class, you can't modify it in a derived class like raspberry. So what do? What if I demand that you make this private? Okay, well, one option would be I could try something like this. I could say, I could just make a member function to set the number of seeds, and then you give me new count. If I do this, then instead of actually setting numSeeds directly, so I say numSeeds equals new count. If I do this, then I'm not allowed to run the assignment, but I could say set numSeeds to be the count that was given in the constructor. This is a contrived exercise. I would recommend just making numSeeds protected, but I want to show off the various options that we have at our disposal. If I try compiling this, I guess set numSeeds, the compiler has a pretty good point there. Set numSeeds should return void. So I'll try compiling it, I'll get rid of that warning, I'll try running it, and we'll notice that the raspberry class still does have 6 seeds. I was able to set the number of seeds here. Perhaps the seed fruit class wants to do this as a way of preventing a derived class from setting the number of seeds to be negative or something, in the usual fashion that we can use these set functions as a way of gatekeeping our data. But this is still a problem because now any member of the public can set the number of seeds. So I could do this. I could actually make the setNumSeeds function protected. So derived classes, the child classes, raspberry and pumpkin, can call this function. They cannot directly manipulate this. Anybody can get the number of seeds. Only the descendants, only members of the family can set the number of seeds, and nobody but the seed fruit class itself can manipulate that number directly. So I could try this. This, I think, is a good example of all 3 layers of access control working together in harmony. And there are lots of reasons you'd want a pattern like this. Although I think this is a bit too simplified for that to be necessary here, this is often necessary. Often when you define something, even if you know subclasses are going to want to modify it, you don't want to let them modify it directly. You want to impose some restrictions on how it gets modified. And so this allows even this intermediary seed fruit class to impose whatever amount of encapsulation it needs.